Now, how thermodynamics science study any machine or component? What is the procedure? To understand the thermodynamic study of any machine, one must know about system and surrounding. Okay, if you want to understand the thermodynamic study of any machine, you should know about system and surrounding first. Okay, so let us begin with the system. Well, what is system? So system is the space where some thermodynamic process is taking place. Okay, any space where some thermodynamic process is taking place is known as system. Well, a thermodynamic system consists of boundaries such that anything outside the boundary is surrounding. Well, these boundaries are hypothetical and imagined by human beings, okay, for analyzing or for problem solving. The boundaries may be fixed or movable. Okay, so what is system? System may be any space, system may be any machine or its component where some thermodynamic process is taking place. Okay, it means if you're studying any space or machine for energy conversion, then your chosen machine or space is known as system. Okay, and during analyzing of any machine or its component or space, a hypothetical boundaries are considered, which is known as system boundaries, and the boundaries of the systems are movable or fixed. Now you can see an irregular shape is considered in the space. Okay, this is known as system. The dotted lines are boundaries of the system, and everything outside the system is everything outside the boundaries is your surrounding. Okay, so any space can be considered as a system in which we can consider the boundaries. These boundaries may be fixed or movable. Okay, types of system. Okay, closed system, open system, isolated system. Okay, there are three types of system defined in thermodynamics, and these are closed system, open system, isolated system. So let us begin with closed system. Well, the system in which neither the system does not permit any mass transfer across its boundary, but only permits the transfer of energy is known as closed system. Okay, it means when energy can cross the boundary of the system but mass cannot cross the boundary of the system, then such systems are known as closed system. For example, heating of water in a closed vessel. Okay, well, another example is your electric bulb. Energy in form of electricity enters into the system, and heat, light comes out of the system boundaries while the gas remains inside the bulb. Hence, no mass transfer through boundary of the system. So electric bulb is another example of closed system where gas remains inside the bulb but light and heat can come out of the system. Okay, where refrigerator is an example of closed system. The refrigerant gas exchange heat energy through evaporator and condenser. The heat is absorbed by the refrigerant in evaporator from refrigerated space, and heat is rejected in the condenser to surrounding. Okay, so you can find evaporator and condenser are the two areas where heat energy can crosses the boundary of the system. In evaporator, heat energy is added into the refrigerant gas, and condenser, the heat energy is rejected by the refrigerant gas into the surrounding, that is your kitchen. So heat energy crosses the boundary. The energy as work is also crosses the boundary because it is given to refrigerant in compressor. Okay, because in compressor we are doing work on the refrigerant gas, and the gas is compressed in compressor. The energy is in the form of electricity is taken by compressor, and compressor gives work to the refrigerant gas. So energy is also crossing the boundaries through compressor. Okay, it means that energy can transfer through the boundary of the system but not mass, because the refrigerant circulate through these four components, that is condenser, expansion device, evaporator, and compressor. You can see the refrigerant is traveling through these components and it will never crosses the boundary of the system, but energy in the form of heat or work can cross the boundary of the system. So refrigerator is an example of thermodynamic system. Okay. Similarly, pressure cooker, steam power plant, etc. are also example of closed system for thermodynamic study. Now, open system. Well, in this system, the mass as well as energy both crosses the boundary of the system. For example, the condenser of your refrigerator, individual component, not the whole refrigerator, as in the previous example, only condenser. In condenser, the mass, that is gas refrigerant entering into the condenser, heat is rejected by the gas refrigerant into the surrounding, that is your kitchen. Okay. Then after rejecting heat, the refrigerant leaves the condenser in the form of liquid. So you can see both mass and energy crosses the boundary of the system. So condenser is an example of open system, individual component. Similarly, your evaporator coil and refrigerant compressor is also an example of open system as an individual component. In your evaporator, the refrigerant enters, the refrigerant gas absorbs heat from the refrigerated space and leaves the evaporator coil. Okay, so you can see both mass and energy crosses the boundary of the system. So evaporator is also an example of open system. Compressor, again in compressor the gas refrigerant entered and work as an energy entered via electricity. The compressor did work on your refrigerant to increase the pressure. After raising the pressure of refrigerant, high pressure refrigerant leaves the compressor. So you will see the mass enters and leaves the compressor, that is your system, and energy also crosses the boundary. So compressor is also an example of open system. Air compressor, IC engines, these are also an example of open system. In your IC engine, the fuel energy, that is chemical fuel, is entering into the engine cylinder and burn gases leave the cylinder. Okay, so mass is entering into the cylinder and leaving the cylinder. Energy is also crosses the boundary of the cylinder. So it is an example of open system. So the above component which are studied through the components which are studied through thermodynamics by considering them as an open systems are those in which mass and energy both crosses the boundary of the system. Coming to the isolated system, well, it is a system of fixed mass and no energy or work crosses its boundaries. In other words, there is no transfer of energy and mass through the system boundaries. Okay, or there is no exchange of mass or energy by system through its surrounding. Okay, the example of the example of isolated system is an open system with its surrounding. That is, your universe is an example of isolated system, because we know that right now we know that nothing is going outside the universe, neither mass nor energy. So you can see it's an ideal case. But for an instant, the thermos, which is used for storing hot tea or coffee, can be considered as an isolated system. You can see the diagram. Open system with its boundaries is known as isolated system. The boundaries are the boundaries of your universe. Okay. Coming to thermodynamics.